Pi divided by t is angular frequency, or called as a progressive wave. Three criterions are important. All the particles should vibrate with the same phase. Particle at the origin is displaced from its mean position during simple harmonic motion. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Continuing my discussion on the chapter waves. In my previous session, we discussed few fundamental concepts, important terms like amplitude of a wave, time period of a wave, frequency of a wave, wavelength, phase difference, and so on. And we stopped by understanding a very, very important term called progressive wave. So in my today's session, we will again understand what is a progressive wave, derive an equation called displacement equation for a progressive wave, and finally write the displacement equation in many other forms. So now we start understanding what is called as a progressive wave. So we will understand the meaning of progressive wave. So as I told yesterday, the meaning of the word progress is to move. Progressive, move or proceed. Now, a wave which travels continuously in a medium. I am considering a wave which travels continuously in a medium in the same direction with constant amplitude. What is the meaning of the word constant amplitude? The height should remain the same, which means all the particles of the wave should vibrate with the same phase. Constant amplitude andre all the particles should vibrate with the same phase. Then such a wave is called a progressive wave. So for a wave to be qualified or called as a progressive wave, three criterions are important. Yaudadu three criterions? It should travel continuously in the medium. It should travel in the same direction in the medium. And it should have constant amplitude. meaning to say all the particles should vibrate with the same phase, then such a wave is called progressive wave. Progress continuously in the medium, in the same direction, with the same amplitude. That is what is called a progressive wave. Now, I will derive something called displacement equation for a progressive wave. Make note, this equation is a very important 5-marker for the exam. ಪರೀಕ್ಷೆಯಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಈಕ್ವೇಶನ್ ಫಾರ್ ಅ ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ ಅಂತ ಕೇಳ್ತಾರೆ. 5 ಮಾರ್ಕ್ಸ್ಗೆ ತುಂಬಾ ಮುಖ್ಯವಾಗಿರೋ ಪರೀಕ್ಷೆ. And always problems are asked based on this concept. So we start deriving something called displacement equation for a progressive wave. So I told a progressive wave should travel continuously in the medium, travel in the same direction. It should have same amplitude, which means the particles should vibrate with constant phase difference. Now, I will consider a transverse progressive wave, a transverse crest to trough iruttallva, light wave. Transverse progressive wave traveling with a velocity v. Transverse progressive wave traveling with a velocity v along the positive x-axis direction. So if you can observe the diagram, this is the transverse progressive wave. ಕ್ರೆಸ್ಟ್ ಟ್ರಫ್ ಇದೆಯಲ್ವಾ, ಅದಕ್ಕೆ ನಾನು ಟ್ರಾನ್ಸ್ವರ್ಸ್ ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ ಅಂತ ಕರೆದೆ. ಟ್ರಾವೆಲಿಂಗ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ along positive x-axis direction. The progressive wave is traveling continuously along the positive x-axis direction with the velocity what I call as v. Now my question, students, is initially which particle has to be disturbed? Formation of ripples. You throw the stone, where it is in impact with water, that region gets disturbed. Here, when you have a progressive wave, initially which particle is disturbed? And my common sense says initially the particle at the origin is disturbed. So we have initially the particle at the origin is disturbed. What do you mean by that? It means to say the particle at the origin is displaced from its mean position. Disturbance being displaced from its mean position, and that displacement is given by y equals a c sine omega t. Last chapter we have studied expression for displacement during simple harmonic motion. Y equals a sine omega t. What was A, students? Amplitude of the wave. What is omega? Angular frequency. So to recall again, as the wave starts moving, as the wave starts propagating, initially the particle at the origin is disturbed. Particle at the origin is displaced from its mean position, and the displacement is given by y equals a sine omega t. What is A? Amplitude of the wave. Omega, angular frequency. Now, I will consider another particle P on the wave, which is at a distance x from the origin. Some another particle, yaudo innondu particle, another particle P on the wave at a distance x from the origin. Now, the time taken by the disturbance to reach the point P is, what I am trying to say is, analyze carefully, students. P is a particle which is at a distance x from the origin. Now the particle at the origin is disturbed first. That disturbance goes on traveling and reaches the point P. What is the time taken by the disturbance to reach the point P? We know speed is distance by time. So time is distance x divided by v. So the time taken by the particle to reach the point P is x divided by v. Now, since it is a progressive wave, we say the particle P should vibrate with the same phase as the particle at O. Basic criterion for a progressive wave. All the particles should vibrate with the same phase. The wave should progress with a constant amplitude. Therefore, we say here the particle at this point P should vibrate with the same phase as the particle at this point O. Both the particles should exhibit same state of vibrations. There should not be any phase difference between O and P. Therefore, the state of vibration of P at any instant of time is the same as the vibration of O at a time t minus x by v. Andre, the particle at O initially starts vibrating. The disturbance has reached the point P at a time interval x by v. Time is distance by speed. So for a time which is t minus x by v, the moment it starts vibrating t minus the time it has taken to reach P, they will have the same state of vibration. So P is vibrating with the same phase as the particle at O in a time t minus x by v. Therefore, the displacement of the particle in a time t minus x by v, generally displacement is a sine omega t. But now the time is t minus x by v. So y equals a sine omega t minus x by v. This is called the equation for a progressive wave. Now, we will write down the other forms of the displacement equation. They are all important for us to work out numericals. Based on what data is given, we select one form and write down. Now, I have derived the displacement equation as y equals a sine omega t minus x divided by v. I will make certain manipulations, modifications in my original equation to get back the required ones. Now I say omega equals 2 pi f. Omega is 2 pi f, which is called angular frequency. So substitute for omega here. So y equals a sine 2 pi f t minus x by v. This is one form of the progressive wave, where we are simply substituting for omega as 2 pi f. What about time period? Omega is also 2 pi divided by t. We told no, f is 1 divided by t. So substituting that, y equals a sine 2 pi, t I take inside, t by t minus v into t, one another form. Very simple. F is 1 by t. Take that t inside the bracket. So t divided by capital T minus x divided by v into t. But what is v into t? Lambda, velocity into time, is some distance. What did we call that distance as? Wavelength. So v into t is lambda. So a is, or y is a sine 2 pi t by t minus x by lambda, which is equation 3. Now, taking 2 pi inside the brackets, so 2 pi by t minus 2 pi x by lambda. Here 2 pi by t is called angular frequency. 2 pi f ಏನਿತ್ತು ಅದನ್ನೇ 2 pi divided by t is angular frequency represented by omega. 2 pi by lambda is k, which is called angular wave number. 2 pi by t, angular frequency. 2 pi by lambda, angular wave number. So we also write y equals a sin omega t minus kx, and these are the various forms of the progressive wave equation. So students, in my today's class, we understood what is a progressive wave, traveling continuously in a medium, same direction, same amplitude, where all the particles have the same phase. I derived the displacement equation for a progressive wave and all the other forms of the displacement equation. Next class, I come up with speed of a transverse wave and principle of superposition. Until then, have a nice time. Thank you.